If you've traveled by train before, you might have noticed that your phone's signal is often weak and frequently interrupted. While this experience might be inconvenient at best for entertainment purposes, I want you to think about the consequences for sensitive applications. For example, if we're controlling a delivery drone or exchanging data between self driving cars, those sudden dropouts might be dangerous. So, the seamless connectivity experience is not just a luxury, but a necessity. Let's understand why this happens by following a signal that's transmitted our way. Now, when the signal is transmitted and sent to us, it's often reflected and scattered over the obstacles that are present in the environment. Now, this creates multiple replicas of the signal, and some of those replicas may travel a longer path, which creates delay. Others might bounce off a moving vehicle, or because we're moving, they're bouncing with a change in frequency. Now, when we have those signals, we can see them, those replicas, we can see them in the geometrical abstraction here on the right, each with different time and frequency shifts. When those replicas arrive to our device, they may interfere with one another, either in time, frequency, or both. This interference and overlap between the replicas makes it so much harder for our phone to process and detect the correct signal. This is the reason why we have those sudden dropouts and weak signals in high speed trains. To overcome those challenges, our work proposed pairing the information signal with the chirp technology. We use chirp signals specifically because they are robust to time and frequency changes. Also, we can optimize them such that we can eliminate the interference that occurs because of the changes and the obstacles that are in the environment. Indeed, using the chirp modulation system can effectively distinguish and process each of those replicas separately, such that we eliminate the presence of interference. This means that we can process and detect the signal much more effectively and reliably. And our simulation results show that the proposed system outperforms current solutions and also offer 20 watts less power. This work can be extended also to space systems and aerial communication systems. This work builds a strong foundation for 6G networks and beyond, especially since that vehicular communication and high mobility communication systems are inevitable in the future.